Hey everyone, and welcome to another episode. Today, we're embarking on an intriguing quest into the orb of calendars. We'll peel back the layers of time and delve into the mysteries that surround our world's chronicle, the calendar. Our main focus today is on a topic that has intrigued many, a peculiar occurrence that happens every 4 years: the leap year. So, you might have found yourself pondering at some point, what's the intricate deal with these leap years? A leap year, in the simplest of terms, is a year that is generously granted an extra day, making February, the shortest month, a day longer, thus marking February 29th on our calendars. While this initially seemed like a random, arbitrary addition, it is in fact a carefully calculated adjustment that serves an integral purpose. This purpose is to keep our human-conceived calendars harmoniously aligned with the Earth's precise revolution around the Sun. Shedding some light on this, let's talk about Earth's journey around the Sun. Here's a fascinating fact. Our planet Earth takes approximately 365.25 days to complete one full orbit around the Sun. However, our conventional calendar year contains 365 days. This discrepancy, although seemingly minute with a quarter of a day's difference, creates a notable gap of leftover. This gap might seem inconsequential, a mere 6 hours. However, think about the accumulated effect over the years. This continual accumulation of leftover time over several years can create a significant rift, throwing our calendar seasons into disarray. Our calendar seasons, namely spring, summer, fall, and winter, would gradually start to drift and would not align with the actual climatic and astronomical seasons of the Earth. It's much like a clock that's slightly off. Over time, that little difference adds up, and before you know it, your clock is noticeably out of sync. The introduction of the leap year, thus, acts as an essential corrective measure. Leap years perform the crucial task of adding that extra day, bridging the gap, and thereby ensuring that our calendar is roughly in sync with the Earth's actual seasons. A little adjustment every 4 years keeps our calendar on track and our seasons consistent, ensuring we don't end up celebrating Christmas in balmy July. So, in a nutshell, leap years bring about harmony between our human-made calendar and the Earth's natural timing. So let's appreciate the leap years, those unsung heroes that bring balance to our calendar and, in turn, to our lives. Leap years add that extra day to bridge that gap and keep our calendar seasons, spring, summer, fall, winter, roughly in sync with the actual Earth seasons. So without leap years, February wouldn't always be the coldest month, and holidays like Christmas wouldn't fall in the winter. Not every year is a leap year. Here's the rule: a year is a leap year if it's divisible by 4. But there's a twist. If the year is divisible by 100, but not by 400, it's not a leap year. Confused? Let's break it down. 2000 is a leap year because it's divisible by 400. But 1900, even though it's divisible by 100, is not a leap year because it's not divisible by 400. Did you know? The extra day in a leap year was actually Julius Caesar's idea. Some cultures celebrate February 29th with special traditions. Babies born on February 29th are sometimes called leaplings. So the next time you see February 29th on the calendar, you'll know the reason behind this extra special day. Thanks for joining us, and see you next time for another science adventure.